Okay, guys, so welcome back to yet another episode of DSA Python series. And today we will be looking at although traversal, Dingling traversal. Okay. Hmm. So we were doing singly linked list, right? Give me a second. Okay, so array in linked list, right? So what we will do, we will have this. We have already created this def function, okay, and the class node. So whenever we will call this class, we will get the value, right? This will be created, okay. And self dot next is none. As of now, this is empty. So this will be empty, right? So um, for creating the uh, array to list, okay. So first we will what is array to list? Linked list, okay. So we need to create first this head, okay. Then only we will traverse one by one, okay. So how do we create the head? We will uh, we will create a new node, and then we will have this head, right? Okay. So first of all, we will create this function only, okay. This is created. So if we talk about this append, okay. So basically, we need to create. hmm, if we are creating this list, okay, if we are creating this type of list, we need to append the elements one by one, right? We need to append these nodes one by one, okay, on the linked list, right? So so array to list, we have this created a function, and So I need to create a new node first, right? I will be creating a new node. Okay, so new node. Sorry, new node is equal to what will be my new node? Whatever is the value. Okay. Uh, so I need to call this node. Okay. So new node will be node of, let's say, val or here data. Okay. So node I have created. But what is the now? I'm creating this new node when this head is none. So head dot head is equal to none, right? Then my head is equal to new node, right? My new node is created. So this will be self dot head. So if that is vacant or say it is none, then I will tell it that my self dot head will be equal to my new node. Otherwise, I'll assume a variable current, and I'll say while current dot next is not none, current is equal to current dot next, and the current dot next will become the new node. So now we can go with the next step. Okay, so here self dot head, I have assumed new node. So if self dot head is equal to none, then this. Otherwise, so in else part, let's write the else. But I'll write is not equal to null. So my current dot next, it will iterate current dot next, and my current dot next will become new node. Do I need to return? Data is not defined. Okay, so here I have to do ARR. Hmm. Okay, so I need to do this. First of all, I'll say that my head is node of ARR of 0. Okay. Prime range 0 to 1. I need to define this. Okay. M is equal to lemon of A. So let us assume current is equal to head. Okay. Now I'll start from 1 and 0. Current will be equal to current dot next, right? And how will we print the node? Okay. So new node will be my this node is equal to node ARR I. So this is my formula. What I'll do is I'll say current dot next equal to new node current plus equals 1. In the end, new node I need to return head. Yeah. So what I've done is I have created first the class node, so which is already given. So first I need to create an empty node. Okay. Then we will create a class solution where I will define array to list. We will be giving it an array input. Initially, we will define the head as node of ARR of 0, right? First, we have created this head, then we will assume this head is current. I will learning path is I am bit contributing. So okay. So shallow copy and deep copy. So basically, Python provides copy.copy for shallow copy and copy.deep copy for if you want to do deep copy. Okay. Whereas deep copy uh, creates a separate object and any change made does not affect original. Yes, actually, shallow copy creates a new outer object, but the nested object inside are still shared. Okay, and deep copy it creates, I would say, completely independent copy, and that will also include the nested object as well. Hmm. Okay, so I hope it clarifies this thing. Okay. Now let's try doing the question. Let's try inserting. So you are given the head of singly linked list, right? So head is already given and a value x. Okay. Insert that value x at the end of the linked list and return the head of the modified linked list. So it means that I have to, if this is my linked list, okay, and input is x equals 6, then I have to put this 6 in the last. Okay. So what I have to check in the end, this next value should be none. If this node 5 ka next value is none, it means that now this node can be inserted, right? That is the whole idea how we operate the singly linked list, right? Okay, you can see the constraint 10 to the power 5 number of nodes. Okay, so often complexity may we can do, right? So okay, so what I'll do, I'll just traverse through the mm, current dot next. Okay. So I'll say that if current dot next is not none, right? While current dot next is not none, then mm, so do I need to iterate? We can iterate, or we can just directly do uh, for loop, while loop. Okay, let's do that first. For I in range 0 to n is equal to n. Okay, head is already given, it's saying. So let's say I consider my current is equal to um, node of I need to see this node also, right? Node of head of 0. Okay. So what I do, I'll traverse through this equal to current dot next. Okay, when if current is not none, right? If current is not none, then I'll do current is equal to current dot next. Else I'll just do I'll attach the node in the end. So current dot next will be my new node. So this X wala node I have to create first, right? So my new node is equal to node of X first, right? And this new node I have to, you know, uh, current dot next is equal to new node. Okay, return head. Then head. So we can do while loop, while current is not done. Remove this. Node object is not. Node of head on 0. Current is equal to head. I simply say current is equal to head. Right. Current is equal to head. If head is not none, then we will simply return new node also. No? If head is not none, I'll simply return none. New node. Okay, so output is coming. It is wrong. Okay, so I have to write if head is none. then I'll return new node. And goes too far. Welcome. Okay, so current dot next is not dot next is not. Okay. So the thing is, first of all, we you are given head of a single list and value x. Okay, so this is my head. Insert value at the end of the linked list and return the head of the modified linked list. Okay, so what I'm doing is, first of all, I'll create a node. Okay, I'll create that node. So new node is equal to node of x, but we don't know the value as such yet, the address of the node, next node, right? So what we'll do, we will just simply assume uh, current equals the head. Okay, so my current input is head, right? And what I'll do, I'll see whether every current का जो next element है, if it is not none. Okay, so this is not none, this is not none, this is not none, this is not none. After that it is none. So once uh, it will go next. Okay, since it is not none, it will go next, else it will go the next current dot next will become my new node. And what is my new node? New node is node of x, right? What if my head is also none, like there is no linked list? So I have to give this condition. If head is not none, I'll simply return new node, right? It means that I will have just one node whose value is x if the head is none. Okay, so this is how we gonna do this. Okay. Sorry. Now, So guys, this was the concept of linked list, and we will continue linked list tomorrow. How we can delete the elements, how we can design a linked list, how we can search an element in the linked list. So all those things we will do, and then after we'll start doubly linked list, okay, which can traverse on both the direction, right? That we will do tomorrow. Okay, so till then, bye bye and take care.